Hello, everybody. This is just some hints for the weekly assignment number 2. I am going to be collecting this and grading it, meaning I want you to have the right answers, not just throwing down some numbers. So, some of these are hard problems. I understand that. I realize that, and that's why I put them on there. So, I'm just going to give you some advice, some hints to help you do these problems. So, number 1, we got the sum of the angles of a triangle. That's 180 degrees. The question is asking, what is the sum of just those ones? So, if you look at the 3 triangles that are drawn in there, add up all the angles. A plus B plus N, that's one triangle. Plus the angles of the other triangle, C plus D plus P, that's another triangle. The third triangle on the bottom, add on the angles, E plus F plus R. What does that equal? Well, you have 3 triangles. This triangle has a sum of the angles of 180, that one's 180, that one's 180. We just added up all those angles. 180 plus 180 plus 180 is 540. Now, the question is, what is the sum of those ones? So if you look at this equation that we have here, it's all addition. You can rearrange the order of addition any way you want. So I'm just going to group the ones that we're looking for. A plus B plus C plus D plus E plus F. This is what we are looking for. Now, what we have left is plus angle N, plus angle P, plus angle R. That equals 540. So, you were trying to solve for this parenthesis. Think of that as your x. You got x plus whatever angle N is, plus P plus R equal to 540. Look at your picture. What do you know about those 3 angles? And there's your answer. Okay, for the next one. You have a car traveled 3 miles south, so we're going to start here. Goes 3 miles south. It goes 9 miles east. Gets to this point. Then it goes another 9 miles south. Ends up here. The question is asking, what is the straight line distance between the point where the car started and where it stopped? So straight line distance from start to stop. This is what we're looking for, that distance in blue. Now, you could, or what you notice here is you got right triangles. Okay, you got 2 right triangles, but the problem is you don't know what that distance is. You don't know what this distance is. So we got to think about this a little bit differently. We do have some right triangles, but we're not going to use those ones. Look at this right triangle. How far from the start to the end did you go south? How far did you go east? Here's one big right triangle where the hypotenuse is what we're looking for. So the question is, how far did you go south? How far did you go east? Now you got a right triangle. Think Pythagorean theorem. For this one, you're going to have to do a system of equations. Okay, you got a vendor sells large sodas for 70 cents, small sodas for 50 cents. On one afternoon, it's a busy afternoon, sold a total of 1,000 sodas for a total of $580. How many large sodas? All right. So, if we let the large sodas be X and the small sodas be Y, it was 70 cents for each large soda, plus 50 cents for each small soda. In that one afternoon, if you take 70 or 0.7 times X, that's how much money was brought in for the large. 0.5 times Y is how much money was brought in for the small. When you add them up, that's the total number of dollars that was brought in. That's one equation. You can't solve this one by itself. You need something else because you got these 2 variables and only the single equation. So, there was a total of 1,000 sodas. A certain number of large plus a certain number of small sodas. You add those up, not 8, you get 1,000. Okay? Here is your system of equations. So to solve for x and y, which we really only need to solve for the large number of sodas, we really only need to solve for x. What I would do is either substitution or elimination. Okay, so those are the methods to solve a system. So we'll just get you started. It's probably going to be best, since we only need to solve for x, I would solve this bottom equation for y. That's 1,000 minus x. Take this, 1,000 minus x. That's what y equals. Plug it into the other equation. Now you got an equation with just x's in them. Solve it.